machine is a special machine, okay, which we design, okay, and manufacture, okay, to the different codes that are managed, okay, when it comes to fabrication, manufacturing, okay, that is Aspect Section 9, 8.1.1, okay. Why the pen test machine? Let's understand this. Okay, welding is an art, okay, blended in science and engineering, okay, and of technology. Which means during the welding process, what happens is the welder is making use of science, engineering, technology. The weld is a permanent qualisence, okay, some quantity, okay, that is deposited across the members. Okay, to hold two joints together. Okay, but the joint must have the desirable mechanical, the desirable mechanical properties that are expected of that joint, okay, to support the service loads. And these mechanical properties that are expected in the base metal are dependent on the microstructures. It is very well, guys. Microstructures that are left in the weld metal of a wood. So we established a welding procedure specifically to enable us have the practical steps which we're supposed to follow. That is, the welder follows in the welding of a test piece or maybe a production weld, so that the deposited weld metal is going to have the desirable mechanical properties that are expected of it to be able to support the service loads. Okay, so procedures are expected to be qualified, which means we must be sure that the deposited weld metal has the desirable mechanical properties, okay, that will support those service loads. That is why we qualify the procedure. Okay, we have the test samples that are welded to school, that is the standard of welding engineer. Okay, and then we do verification, okay, of the deposited weld metal, okay, using inspection, okay, which proceeds with visual inspection, and we have to proceed to mechanical testing, okay, after non-destructive testing. That is procedure qualification. So we are talking about the pen test machine, the new product which we are placing, which we designed, manufactured, and placing in the industry today. The pen test machine constitutes part of the welder qualification process. During the welder performance test, okay, what are we targeting? What are we targeting? What are we targeting? We want that the welder should be able to deposit a sound weld, okay, following a welding procedure specification, which, if verified, okay, maybe through the inspection methods that are available, okay, it should meet the design specification, that is the code standardized manning the construction construction. Maybe it can be Aspect 9, it can be 8.1.1, or maybe API 6, maybe API 1104. So these welders are qualified to different codes. Okay, so in the process of welder qualification, we make use of the bend test machine. And why the bend test machine, or the purpose of the bend test machine? We have acknowledged the fact that, okay, the welding process, to establish a weld, we require a procedure. That procedure is well established beforehand, and the welder is expected to follow that procedure and execute the work. So this procedure enables us to be sure that the deposited weld metal is going to have the desirable mechanical properties that are expected of it to support the service loads. So, if the welder is ignorant about or cannot comply to the welding procedure, that is already a problem. The welder must understand that there is interpass temperature that's required. Respect interpass temperature. Understand that maybe the heat input is required for that joint, because the welding process will make use of heat. This heat raises the temperature of the base metal from low temperature to high temperature and causes diffusion, okay, and diffusion. And you have the permanent quality, which is the word deposited across the joint. You see that? So we are saying that the welder must be cognizant of all of this, so as to be able to carry on a good weld, okay, that's going to have the properties that we expect of it. So, what are we seeing here? We are saying that a welder who does not follow the welding procedure is a problem. We can have a weld that is welded. Okay, look at it, it's good shiny, but that is a bad weld. Okay, because of maybe insufficient heat input or excessive heat input. Okay, so we are saying that the use of the welding procedure specification or execution of welding procedure specification is primordial for the quality of the weld. Okay, because in that case, you have the desired amount of heat input, the control amount of heat input that is fully established, okay, and calculated, that is supposed to be executed by the welder during the welding process. So using maybe the electrical parameters. Consequently, the welder is supposed to 1% of this, okay, knowing that okay, I'm going to use these electrical parameters, okay, my interface is supposed to be this amount, okay, this temperature maybe 150, this maybe 100 degrees, okay, and respect all of that. So we will show, okay, that word will meet the design specification. So you might have a word that, okay, maybe it's a question of maybe saying that I don't have slack nutrition, I don't have under course, I don't have slack porosity. The word might be clean, okay, no indications in it, but it's a bad word because it lacks the microstructures that we expect of it. Okay, so the word have the desirable microstructures. Okay, so it will enable that weld metal to have the desirable mechanical properties that we expect of it service. So that is the essence of welding procedure. And this bench test machine is going to make us be able to evaluate the candidate or the welder, okay, on his welding procedure performance specification, compliance, motions. It understands the very values, the very importance of the welding procedure specification, and duly respects. It's not a question of the welding inspector following him like a gendarme, maybe the welding supervisor following him like a gendarme. He is a knowledgeable welder, okay, who understands that no, I have to follow this procedure, okay, so much that I want to have the desirable mechanical properties. Okay, and to have these properties is because I have the desirable microstructures, and this depends on the heat input that's required. So I must put the required heat input. I don't have to weld one electrode and go and spin around. Okay, make two phone calls. Okay, they come and work the next electrode, and go there and get another call and another electrode. That is a poor word. Okay, except that the procedure accepted that in that case maybe welding some stainless steel. Okay, so we are saying that the welding procedure is very important. Okay, because the welding engineer is seeing that we establish the mechanical properties of that material across the joint during the welding operation. So we make use of welding, the different welding processes. So the welder's ability, we're checking the welder's ability. You said he understands the use of that welding process, okay, to deposit both the weld metals required, okay, following the welding procedure specification. So we can verify that, okay, for welder qualification, okay, if the procedure for welder qualification, okay, the test piece goes to visual inspection, okay, that the welder was test coupon like this, okay. What's a test coupon like this? Okay, the piece is inspected visually, do visual inspection. Okay, if the piece is accepted, okay, maybe worded to maybe different codes like maybe ASME section 9 like this. Okay, ASME section 9 is going to tell you the criteria, okay, that are applicable when it comes to inspection of the work of the test coupon. Okay, visually. So the acceptance criteria, maybe you look at the ASME section 9, maybe 194 there gives you the criteria of visual inspection. So the criteria there, once this piece conforms to this acceptance criteria, that is performance test coupon shall show no cracks and incomplete joint penetration and weld metal and with complete interest of weld metal and base metal. If this criteria is met, the piece is accepted. The piece is accepted. Then you can move the piece to the next page, which is mechanical testing. That's the bench test. At that level, samples are extracted from the piece. Okay, this is the coupon. We extract samples from the piece. Okay, we extract samples from the piece. Okay, according to the description of the code. Okay, these samples are carefully extracted like this. Okay, for hook and face bends and side bends. So that depends on the description of the code there. So you have the root bend sample, this, okay, cannot extract to the dimensions. For instance, you can have this 68 millimeters there, here, 8 millimeters. Then you have, that's the root bend, for the root, and then you have the face, okay, and then you have the side bend. Sample there, the side bend, okay. So they have been extracted from the welded pump. But take particular attention, the piece must have been accepted visually, and then move to this next stage of which we call the mechanical testing using the bend test machine. So that is where Mr. Bend test machine intervenes in the qualification process. So this machine now is very important. Okay, with the bend test machine now, okay, we're going to bend these samples. Okay, that's from this. It's a sample analyzed. Okay, that is with bend and use the bend test machine, and we don't have any indications. Okay, the indications as spelled out in the code, then the piece is accepted. So let's proceed there. So proceed our first sample there. This is the samples for side bend. Okay, so two samples of side bend. So this sample of side bend, okay, look, dimension there, okay, are supposed to be 10 millimeters. 10 millimeters. Yeah. So put it there. So the machine will be carefully designed. Okay, put that carefully designed. Okay, accept just 10 millimeters. Okay. 10 millimeters. Okay. So put it there. Go through. About 10 meters will not go through. Okay, about 10 meters go through. The word is at the center. The word is at the center there. Okay, so this is the first okay, this is the first part. Check the mask very well. Okay, so we have the place at the center. Okay, and then we proceed. Okay, there we have it on. Pull it. Okay,
Police! Okay, busy.
okay, that sample fails. At the sample, it fails. Here, another sample. guys. So you see these are the bent test samples. Okay, we'll bend them. Okay, using our bent test. After the bent test, the next thing is to do inspection. Okay, if you look at this sample fails. The side test, but then you have to measure it. Okay. Okay, look at this. The face bend. Okay, the face bend. Okay. Normally, you look at it. Okay, I'll do proper inspection. Okay. And make sure that because according to the code, okay, we have the acceptance criteria. Okay. So look at the indications that are visible. No visible indication should be more than 3 millimeters. So, as we have seen, those are the test samples. Okay, this tells us that there was a problem. This welder has a problem. Okay, 2 of these test samples failed. Okay. Even the visual inspection of the test report was not accepted. You see there? So, it fails. You see there? Yeah. So, if we didn't have this, okay, nice. So, guys, what are we seeing here? As welders, the use of the welding procedure to follow the execution of the welding procedure is for the execution of the weld. Because that weld is supposed to have the desirable mechanical properties, and those desirable mechanical properties are dependent on the microstructures that are present in the deposited weld metal. And that is the very essence, the very problem the welding engineer has. You see that those mechanical properties of the base metal, are re-established across the joint during the welding process. And that, okay, the welding process is established, heat input, control, that so much that you as the welder, you should follow it so much that you have good words. See the guys? So that is on the basis. So you proceed that which means this has failed. More heat input. You want to electric go out there, spin around, come in, go around electric, go around, spin around, come on, go around electric. Okay, that's why yes. Low, the heat input is not accurate. Like just like okay, you're just shield casting. Okay, that is glass on the person. So you have to respect the heat input. You know, plus there's an amount of heat that is required to that drawing. You make sure that you respect that amount of heat. You see it there? If you don't respect that amount of heat, what you are doing there is just nonsense. Absolutely. That's what I'm saying there, guys. Yes. That is the very essence of welding. Okay? Welding is not just an art. Okay, that is what you want welding it should be shiny. Okay, shiny like this. It is both an art, a science, okay, and it involves technology. It's applicable there. You see that? So okay, if you let your welding be shiny, okay, you miss the point. Because you just go out there, weld and come back and weld. Your end result is like, okay, I want it to be shiny. No. Have properties that we're looking for, okay, and those properties must be present in the base metal for in the welded deposit weld metal for us to understand that this is good well. Get it there, guys? For welder qualification, okay, and qualification of welding procedures. So if a welder who is qualified using the bend test is a good guy. He's a good guy. He knows that guy is a knowledgeable guy. He knows so many things. He has so many things in him.
Yes, sir. So another can see past the radio and see the bend test.
That is what I'm saying. Radiography is just going to. Radiography is what radiography does. It just checks if you have any dirt. I'm calling it dirt. What do you call the indication? Okay. If you have any slack inclusions, lack of fusion, or maybe a porosity in there. If there's nothing like that, okay, it's accepted. No undercourse, no undercourse here. It's accepted. But it doesn't tell you if the if the microstructures are the adequate microstructures that are required. And that is only possible. You can only be sure of that. You want to test it and be sure of it, that the microstructures are okay. test. When you tell them, okay, that is the weather, respected that welding procedure, the heat input was right in service meter. That is a knowledgeable guy. You understand? I'm not just welding this stuff. That's why you see on many some projects that done. Okay, and then before they get into services, maybe the project was maybe the last 5 years, 2 years, this problem already. Maybe you find the structural components developing cracks all over. Why? Because the process were not respected. The way that's maybe some of the inspectors maybe just rely on the radiography. Okay, maybe the ultrasonics. But if they do not have those guys who are knowledgeable, that problem have problem. Sorry, that project have problem in the nearest future. They will not see that then. Because just maybe to 2 years, oh, you see that it's collapsing. What's happening? But what we did on engineering, right? What is happening? Is it magic? It's not magic. Those guys do not respect the welding procedure.